Okay, we worked number 7 on this sheet, and I think it's probably good to work number 9 as well to show you another perspective here on things that are rising. In number 7, we had a rocket that was thrusting, and so remember, every time you have a thrust, and we'll talk about this more. If you're in rocketry, you've talked about it. We'll talk about it more in the next sheet. But for thrusting, you must have some type of escaping. Usually, it's escaping gases, hot gases coming out the back of a rocket. Which then, so if you have escaping gases coming out the back of this rocket, that propels the rocket forward because of Newton's third law, which we're going to hit in detail. So thrust, propulsion, different kind of things. Here we have a balloon, and this balloon is not rising because there's a hole in it. If it was, it would be considered a cold gas rocket. But in this case, it's just rising because of buoyancy of air. So yeah, you could draw a balloon, but all I really care about is the center of mass of that balloon. So in number 9, it says a helium balloon rising at 10 miles an hour, not very fast, at 80 degrees to the horizontal, with the wind gusting horizontally from the left. So we will first, what you're going to do is get your forces on there and then look at the sizes of those forces. Okay, the lengths of those forces are going to be important. So here we go. Let's change colors here. I'm going to I always start with mg down. Now I'm looking at a balloon here, so my mg can't be very big, right? I mean, relative. It's all relative, but if I have a balloon down, if it's rising, I must have a lot more buoyancy. So speaking of buoyancy, let's go ahead and put it on there. Buoyancy has to be larger, and that depends on that's buoyancy of air, not water. So B sub A. So buoyancy depends on pressure differences from the top of the object to the bottom of the object. So in air pressure, there is a little bit of pressure difference as you rise. So there's enough to get that thing to rise up. So this buoyancy, this balloon is rising. But in addition, it's not rising straight up in the air. It says it's rising 80 degrees to the horizontal. So I want to go, and I'm not going to get a protractor out, but 80 degrees to the horizontal, somewhere in there. If we were asking you to construct, you need a protractor, but these are supposed to be sort of sketches. So there is my different color here. Whoa! Here is my DOM. In DOM should be a dotted line. It could be solid if it was a different color, but I wouldn't have made it dotted. Notice I didn't make it an arrow that time, and I could. But I want to be better than that in this case, because I do have that at an angle thing. So this thing is it's rising, it says at 80 degrees. Okay. And then I'm going to have the force of wind. So let's add the force of wind to it, keeping in mind that I may have to adjust the length of my vectors in a little bit. There's the force of wind, and my mg down, and my buoyancy up. Okay, and there must be one more thing. Remember, air drag. We talked about the formula for air drag is RA. And I talked about this earlier, but RA equals 1/2 d rho a v squared, and we'll get into this more later. It's a force, but the point is d is a drag coefficient, rho is the density of the medium that is traveling through, in this case, air. A is the important thing here. It's either A or velocity or some combination. Well, in this case, the velocity of the balloon is only 10 miles an hour, so that's not playing a big role in the air drag. But you know, a balloon has got a huge amount of area, and this A is not talking about surface area, it's talking about profile area. So the balloon's moving this way, it's the area that's exposed. So when I blow a balloon up, you can see so if this balloon is rising at some angle, 80 degrees, this, remember, well, like I showed you in the last one, when I'm looking at it, this is what I see. It's almost spherical. Here's the huge amount of profile area. Not surface area, but profile area. It looks like an oval, like an egg coming at me. And so there's approximately pi r squared there, which is pretty big value. So, all right, so there is air drag, mainly because of the A. And that's going to come back always opposite the direction of motion. And I'm making it that long, I'll adjust it later. All right. So now let's look and see, we got all this established. Now let's check and see if our lengths look good. And so remember, you add up the summation of the vectors head to tail is going to give me my resultant vector. This time my resultant vector is not 0. My resultant vector is a vector in the direction of motion, not opposite. There's only 3 choices. Your resultant vector is 0, your resultant vector is in the direction of motion, or your resultant vector, if it's negatively accelerating, is opposite the direction of motion. Like when you slam on the brakes of your car, your resultant vector will be back, opposite your direction. But anyway, here we have a resultant vector that's in the direction of motion. So if I add up my B vector with my force of wind, I already see I'm in trouble, it looks like. Actually, let's go ahead and do it this way. Let's do it vectorially. B, and when you do it vectorially head to tail, you don't need to worry about X or Y. Remember that head to tail construction? We weren't putting into its I or J components.
Teacher, pardon this interruption, but before we start, we have a little announcement.
Okay.
Okay, hey guys.
So I'm going to keep writing over this announcement.
Next week is Flights Week, and Monday is Lazy Day, so remember to wear your pajamas to school. Thanks.
There's nothing else positive.
Okay, so now make sure you put up your classwork, grab something you want to read, and then stop talking and read something.
So minus, okay. Cool. All right, so the direction of motion's this way. Oh, but I'm just adding up vectors here. So it's BA minus MG, and I put the little symbol arrow above it. I'm talking about vectors. I'm talking about actually head to tail thing. Oops. Sorry. I'll edit all this out. That announcement threw me off. When you're adding them up head to tail, you don't need to put minus or plus, okay? Because head to tail method, when you actually put the arrow on the page, its direction will be involved. So don't need to say minus here. Plus RA plus FW. All these have to add up to my resultant. Okay, I'm just going to put an R there. Now, I know, like I say, the problem did not tell me how long the resultant was. Now, it did say it is going, well, no, wait a minute now, hold on a minute. Let me read this again. It said it's rising at 10 miles per hour. It doesn't say it's speeding up, does it? I need to rewrite this question because I was kind of assuming it was accelerating. If I say 10 miles an hour, you could interpret that to mean it's rising at a constant rate of 10 miles an hour. But, and that can happen, but I think in this case I want to make it accelerate. Okay, so we're taking a snapshot. It's accelerating from 0, and once it left the little boy's hand, or little girl's hand, lost her balloon, and now it's accelerating up to a faster speed. Has that gust of wind. The buoyancy will remain fairly constant because it's the difference of the pressures on the top of the balloon and the bottom of the balloon, at least for the first 500 feet above ground. As the balloon will start to get bigger as it rises, but because of lower air pressure, but let's not worry about that. Okay, so let's go ahead and make it so it is in the process of accelerating. Let's give it a little bit of R. All right, so BA is up. Let's see if this will work out the way I want it. I want my R, how about this? I want my R to be like that. I don't want it to be real big, but I do want it to be in the direction of motion. Okay? So I want these 4 arrows to add up to give me the red arrow. So it's not going to give me a quadrilateral. It's not going to be a 4-sided polynomial or polygon. Sorry. It's going to give me I'm going to end up with a pentagon, right? When I add up the R vector to it, because I want to have a 5-sided figure. So these are going to be 4 to the sides, going to be the 5th. So it's got to work. So here we go, and it's got to work specifically to give me that R. So I take that FW, I bring it up here, and I get something like this comes out, just repeat that up there, head to tail method. And then I bring my mg and I bring it right there, add it up, bring it right like that, down. And now I got a problem, see, because my RA, if I'm going to bring it up, I'm going to end up back here. Well, I did not connect up to where that resultant vector should be. So I've got a problem. I got to make something smaller, something larger. If I make my mg smaller, let's cut my mg in half. This is the way you do this in pencil. Right down a little bit. I cut my mg in half. That's going to make that vector smaller. Cut that off. I actually have a worksheet coming up where we have to do this with rulers and protractors. It'll be a few worksheets from now. I want to come back and revisit this idea. I just want to introduce it now, get you thinking this way. Then we'll start plugging in some numbers on some, once you get past Newton's third law, we'll plug in some numbers. And then we'll come back and look at this again, this time with rulers and all. Okay, and then if I bring that, I'm getting closer. Let me cut my wind a little bit. I'm going to cut that back, maybe back to there. And then try that one. Okay, there's my force of wind, and that'll bring that back. You see the process you have to go through? But boy, I tell you, this is pure physics. I love it. And if I bring that little one back, if I bring my force back a little more, and then I bring it back so it's right there, then I bring in the RA, now I'm pretty much hitting where I want to be. So that stuff, I don't want that anymore. Let me go through and get my original drawing back. I don't want any of that. It's just that now I get the R out of there. I don't put the R in there. Okay, so now you got it. Okay. So there, if I can get all the thing back, there is my free body with my arrows about the right size. Now, what though I wanted you to do, get rid of these. What I wanted you to do was to give me the components, the I and J components. So let's do that. This is my BA. So now my I and J components here would be down here. In my X direction, I'm going to have FW. I always put the ones I get all of first, then I put the components, and I always put the positive ones first, just my thing. So summation of forces in the X, I'm going to have force of wind. I'm going to have no BA, no MG, but I'm going to get part of my RA. So minus RA, and here's my little triangle. It's not a big one. A little right triangle, and there's my 80. Those are vertical angles. So it's going to be RA cosine 80 degrees must equal MAX, because I am saying there is a resultant. I'll be more descriptive when I rewrite it. All right, and now we go to the Y. I get all my buoyancy. I get all my mg. That's the only positive force I have. I get all my mg, and I'm going to get a portion of my air drag, sine this time, 80, and that equals MAY. Ta-da! Done. Okay, great.